Hi viewers, this is Dr. R. Padmapriya from St.Joseph College of Arts and Science, Cuddalore, working as an assistant professor in PG and Research Department of Mathematics. In this video, we are going to discuss about the topic beta function in calculus. Let us first see the definition for the beta function. The definite integral 0 to 1 x power m minus 1 into 1 minus x whole power n minus 1 into dx when m is greater than 0, n is greater than 0 is called the beta function and is denoted by beta of m comma n. Thus, beta of m comma n is denoted by integral 0 to 1 x power m minus 1 into 1 minus x whole power n minus 1 into dx. Beta function is also called the Euclidean integral of the first kind. Now let us see the symmetry of beta function. That is, beta of m comma n is equal to beta of n comma m. We know the formula for the beta of m comma n is equal to integral 0 to 1 x power m minus 1 1 minus x whole power n minus 1 into dx. Since integral 0 to a f of x dx is equal to integral 0 to a f of a minus x into dx. This is one of the property in the integral. We can make use of this property in this. That is, we have to subtract by the upper integral. Therefore, beta of m comma n is equal to integral 0 to 1. Here the upper integral is 1. So, subtract with that value 1 minus x whole power m minus 1. Again subtract with 1 minus of 1 minus x whole power n minus 1 into dx. It will become integral 0 to 1 1 minus x whole power m minus 1 plus 1 minus 1 get cancelled. So, x power n minus 1 into dx. We can write it as integral 0 to 1 x power n minus 1 into 1 minus x whole power m minus 1 into dx. That is nothing but beta of n comma m. So, we can prove for the symmetry. Here, one of the most important derivation in beta function, that is the relationship between beta and gamma function. Beta of m comma n is equal to gamma m gamma n divided by gamma of m plus n when m is greater than 0 and n is greater than 0. Let us see the proof. We already see in the previous video about the gamma function. We know the formula for gamma m, that is integral 0 to infinity e power minus t power m minus 1 into dt. Here putting t is equal to x square, so that when we differentiate dt is equal to 2 times of x into dx. So, gamma m will become integral 0 to infinity e power, in the place of t substitute x square. So, e power minus x square, in the place of t again substitute x square whole power m minus 1 into dt dx 2x dx. The next step, take that 2 outside of the integral. 2 times of integral 0 to infinity e power minus x square. X, we are having the base x 2 times. So, add the power values, x power 2m minus 2 plus 1 into dx. It will become like this. Gamma m is equal to 2 times of integral 0 to infinity e power minus x square x power 2m minus 1 into dx. Take this as equation number 1. Similarly, we can write it for gamma n value in terms of y. So, 2 times of 0 to integral 0 to infinity e power minus y square y power 2n minus 1 into dy. Take this as equation number 2. Now, multiply equation 1 and 2. Multiply the left hand side. Gamma m gamma n is equal to, multiply the right hand side 2 times of 2 times, so 2 times of integral 0 to infinity e power minus x square into x power 2m minus 1 into dx, first equation. Second equation is 2 times of integral 0 to infinity e power minus y square into y power 2n minus 1 into dy. So that is equal to, multiply the 2 into 2, 4, integral value double integral 0 to infinity e power, e is the same base value, so add the power values, minus of x square plus y square into x power 2m minus 1 into y power 2n minus 1 into dx dy. Now we have to change this into a polar coordinates. X is equal to r cos theta, y is equal to r sin theta, and dx dy is equal to r dr d theta. Therefore, r varies from 0 to infinity and theta varies from 0 to pi by 2. Let us see how it changes. Since r square is equal to x square plus y square, when x is equal to 0, y is equal to 0, then r is equal to 0. When x is equal to infinity and y is equal to infinity, then r value becomes infinity. For the theta value, tan theta is equal to y by x. That implies theta is equal to tan inverse of y by x. When x is equal to 0, y is equal to 0, theta value become 0. When y is equal to infinity, put the, that is tan inverse of infinity. For the theta value, pi by 2. When you substitute the theta value pi by 2, we will be getting the tan value infinity. So the limits change as, for theta 0 to pi by 2 and r 0 to infinity. Okay. Now change this into the polar coordinates. Gamma m, gamma n in the left hand side. In the right hand side, 4 times of theta value is integral 0 to pi by 2 and the r value is integral 0 to infinity. E power minus, there we have e power minus x square plus y square. That is, in the place of x square, r square cos square theta plus y r squared sin square theta. Take r as common, sin squared plus cos squared value is 1. So e power minus r squared. We obtain e power minus r squared. In the next value, we will be having x power 2m minus 1 into y power 2n minus 1 into dx dy. Okay, x power means r cos theta whole power 2m minus 1. Again, y power 2n minus 1 is r sin theta whole power 2n minus 1. In the place of dx dy, you substitute r dr d theta. So we are having 3 base value r value, that is r power 2m minus 1, r power 2n minus 1, r power 1. So plus 1 minus 1 get cancelled. The remaining is 2 m plus 2n minus 1. Next value is cos power 2m minus 1 theta into sin power 2n minus 1 theta into dr d theta. Now separate the r value and theta value. 4 times of integral 0 to pi by 2 cos power 2m minus 1 theta sin power 2n minus 1 theta into d theta. This is the theta value. Integral 0 to infinity e power minus r square r power 2m plus n minus 1 into dr. This is the r value, r integral. We know the formula for the first one, that is integral 0 to pi by 2 cos power 2m minus 1 theta into sin power 2n minus 1 theta into d theta is nothing but beta of m comma n divided by 2. And if we derive this value integral 0 to infinity e power minus r square into r power 2m plus n minus 1 into dr. After derivation, we will be getting this gamma m plus n divided by 2. So, 2 get cancelled with 4. So, beta of m comma n into gamma of m plus n. Therefore, beta of m comma n is equal to gamma m gamma n divided by gamma of m plus n. Thank you for watching.